Did you switch slide sharing or switch off slide?
Yeah, it dropped off.
Yeah,
Unstable connection.
yeah, I've been telling you, not me. Okay.
Or I guess we're at time.
Well, I'll open. Should I open? Or?
Yeah, go ahead.
Okay. Yeah. Let's give one more minute.
Sure.
Yeah, let's give a couple of more minutes for people to arrive. Okay. Okay, I propose we get started. Good afternoon, everyone. This is the Lake Working Group meeting. My name is Melissa and my co-chair is Steven. So as a reminder, this session is being recorded and it is covered by Note 12. All the contributions are covered by Note 12 as this is an IETF meeting. Next slide, please. So if you haven't done so, please sign in using the online tool because to keep the presence logged. And here are some meeting tips for joining the mic queue if you are willing to speak at the mic. Next slide. Yes, please wear masks unless you are actively speaking, eating, or drinking, but we don't encourage you to do so at this time. So here are some resources for the meeting this afternoon. So the agenda, the remote participation link, we have two note takers, I believe, Marco and David. Yes, thank you so much for taking notes. So I guess you guys can cover each other when Marco is speaking. David can be taking notes, and vice versa if David is speaking on the mic. Jabber Scribe, we will be keeping track on Jabber from the chair side. Next slide, please. Yes, in terms of the agenda. So we are in the administrative part. We plan on going over the working group last call comments on the ad hoc specification, the main chartered item of this working group. After that, Mark will be presenting a report from the hackathon and the progress of the traces draft. In the second half of the meeting, we plan on going over the uncharted items, some possible future work that we would like to discuss as an introduction to rechartering Lake. So does anyone want to bash this agenda? I hear no. Yes?
So, Johan Selander, I may have a difficulty running in 15 minutes, the working group last comments, but I can take perhaps from my 10 minutes of the other presentation.
Well, yeah, I mean the chartered items will obviously get priority, yeah.
Okay. All right. That is noted. So with that, I propose we get started with the first agenda item. This is working group last call comments, and Joran, the floor is yours.
Thank you. So I'm going to talk about the latest version and the working group last call comments. Next slide, please. So current version is 17, which is a small update of 16. And that is also a fairly small update, but some significant changes to the wire format, which was caused by the analysis team. So we had 2 significant comments from the security analysis teams, and they also verified the updates after being made. So we also had to update the traces document, which Mark will talk about after this presentation. Next slide. Next slide. So version 16 we already talked about in an interim meeting, so I'm not going to go to too much detail. I just like to mention the wire format changes. The main changes were that the transcript hash 2 is now used as salt in the key derivation for PRK2E, and that credentials R and credentials I are now included in transcript hash 3 and 4. Next slide. And the following. So these were the changes in the very last version. The 2 updates to the security considerations. One speaking about 128-bit security against online attacks, which is very nice, considering these are 64-bit MACs, by verifying multiple MACs. And this was an input from ENS. And the other text is on pair awareness for message 4. Then we also moved the key update function to an appendix, because that's covered by other functionality in a core document. So we changed from recommended to optional. And finally, some clarifications in the appendix on handling large plain text too. Next slide. So here, just to give the picture, I had to do this for another presentation, so I thought I'd anyway share it here. This is the current key schedule for all the modes. Next slide, please.
Yep. My connection is being recovered. Have to share again. Yeah, back there in a sec.
So yeah, great. And next slide. So these are the people who commented on the. We actually got some more comments after the deadline here, but these are the comments I've counted for in this presentation. These are implementers and security analysis teams, and that's excellent. We're really happy for all the comments we got here. Some very detailed and yeah, very good comments. Thank you very much. There is also a last call comment from an author, from John here, on the use of, yeah, we'll come to that later. So there, I'll try to cover these comments now in the remaining time. So next slide, please. Here are the specific issues, which is just a subset of the comments we got, which I think is worth bringing up here. And I think there are 10 issues, so let's get started. Yeah, the first comment is about use of the word session key, which is used mainly in the analysis part, whereas in the rest of the document, when we describe the actual functionality, we use the term PRK out, which is the session key, but that wasn't really matched very clearly, so we have a proposal for tying these terms together in a PR. Next slide. This comment was made by the team, Charlie Jacon and his team, and he noted that the text in the first bullet here on how to detect changes wasn't actually correct. It's correct for strongly unforgeable signatures, so that you can detect changes when you verify the signature or MAC field, but it's not correct in general that you can verify it at this stage, but you will instead be able to verify it in the next message. So, but this needs to be corrected, and without going to the detail of the different properties of signature schemes, there is basically a proposal updating this text, which has been checked with Charlie and his team, and that's now PR 356. So we have a proposal for replacing this formulation with something that is correct. Next slide, please. Here was a comment about the key update. So the key update function has been described, and there is but there was no associated protocol, and that was a question or a comment. And since we now have more or less deprecated the key update function in ad hoc, we propose to not define this in the protocol, since we're using a mechanism from the core working group instead. So that's a proposal. And interrupt me if there are any objections. Otherwise, we go to the next slide. This is a very specific comment from Marco, and actually from Malisha as well. It's about how should we encode the transcript hash 2, or transcript hashes in general. So transcript hash is the output of a hash function. So it's a raw byte string, but we're stating in the document that the transcript hash is a CBOR encoded byte string, because that's what's used in various CBOR objects. It's either a CBOR sequence or a struct, which has a CDDL associated to it. But as of version 16, we also use TH2 in the salt, as you remember. So in this case, it's actually, there is no reason a priori to use CBOR here, because we have the raw byte string, and there is nothing else that is CBOR encoded in this function. So for traces 03, we used the raw byte string in this location, so not a CBOR item. And then, of course, the statement that the transcript hash is a CBOR encoded byte string is very confusing. So we have here two choices. Either we keep the test vectors and this distinction and remove this sentence saying when that the transcript hash is a CBOR encoded byte string, and you can understand from the context when it's either, or we keep this statement about being a CBOR encoded byte string, and in that case we have to make new test vectors. So is there anyone that has an opinion here? We already have an opinion from Marco, but you may want to restate that.
Yeah, Marco, I prefer the first alternative. You mentioned, of course, removing the text and keep the actual value used, as is also in the interest of traces and implementations.
So Marco spent 4 hours doing the test vectors. He doesn't want to do it again. Obviously. Any other comments here?
So we have John in the queue.
Yeah, fully agree with Marco. Don't touch the test vectors, just adopt the specification to agree with the test vectors.
David?
David speaking. I have exactly the same opinion. So the fact that it's a CBOR encoded string is obvious when you create your CBOR, when you CBOR encode your packets.
Thank you.
Okay, so it seems we have consensus to use the raw byte string, but let's please explicitly specify in the instances where it should be CBOR wrapped that it should be done so.
Perfect. Please make an action of that.
Yes, let's note that in the action items.
Okay. And going back, TH3, just the note there. This, as far as I understand, TH3 is only used, I didn't check this, I'm sorry for that. I think TH3 is only used in the CBOR objects. So we don't need to be explicit. And the question is then, should we keep this formulation, the transcript hash TH2, and the transcript hash TH3 is a CBOR byte string, or should we take that out in all? I suppose we take that out in all places. Any disagreement with that? We remove this. We remove the statement about transcript hash being a CBOR encoded byte string because it's obvious from the context. Or did you? Was that contradicting what you were saying?
No, that is in agreement with what I was saying, okay. Actually, because this sentence is what introduced confusion when I was implementing this draft. So this is my point of view. So that would be my chair hat of opinion. I don't know if anyone else has comments. If not, I propose we remove the sentence and reframe.
Thank you. Next slide. So here is another comment which has been, actually, this is the second time we have the comment, so we need to think a little bit carefully if we really should disregard it. So Malisha again, this was a while we had the previous time, asked why don't we have a state machine for describing ad hoc, and he was referencing TLS. And John is replying here that ad hoc doesn't really have the kind of states that TLS 103 has, but he's not against having a figure. So our proposal, the author team proposed that, yeah, we should sketch an appendix and see how this figure looks like, and then we can decide if that is useful or not. And we'd like to have volunteers here, or at least some ideas of how this would look like, because we can't map directly from Appendix A in RFC 8446. And if there are some proposals, then the authors will do it basically. But I'm happy to, or yeah, any inputs here would be yes, very good. Have anyone given it more thought on how it would look like, or just having a state machine would be nice?
So yes, I had to implement one for my implementation, so I'm happy to provide feedback, but we should also run this against the security guys who did the reviews, because they had their own models as well. So we should be a team effort, but I am happy to volunteer to provide some feedback on this. Let's know this as in action items for myself.
So just a question. So how much effort is this worth? If this was going to delay us by 3 months, it's probably too much effort, right? If it's a couple of weeks, it's fine.
Should be straight. I mean, the discussions that we were having, it's except for the negotiation part of the crypto suite, it should be straightforward. So I don't think it will delay us. I think it should be a matter of days, not weeks.
With the good input, I think we can make it in a couple of weeks.
Okay, cool. So we have David?
David speaking. I think maybe you are a bit optimistic, because state machines are like pseudocode, and usually implementers don't read the text and just look at the pictures. And if your state machine is not perfectly aligned with the specification, it may cause problems. So it will need to be proofread to make sure it's
okay,
perfect.
Okay, that's a valid point. Yes.
So can we decide on that? We actually do like what's proposed here, that we sketch an appendix and then we decide if we want to pursue it or if we want to rely on the text instead. Is that a good way forward?
Sure. Yeah. So how about if you're happy to do it, if you kind of just create a little fragment of text, send them out to the list, and if it's all perfect, we whack it straight in. If it leads to a huge discussion, we'll take it out. That seem fair?
Yeah, sounds good.
No. Sounds good. Okay.
Then we got the next slide. How am I doing time-wise?
You're doing good.
Okay. So there one question about processing. I think there is another one coming up. So this is the particular question about handling EAD errors. So we'll talk more about the external authorization data in a later presentation. But the EAD processing is disjoint from ad hoc. So the question from Marco in this case was, how do I apply the general rule here? If you have an EAD item and you have a failure in that, when you process that, does that mean that ad hoc is going to send an error message? And the general rule, as stated at the top there, is that if any processing fails, the responder must send an ad hoc message back. But then we also have a security considerations section 8.7 stating specific conditions where, for example, denial of service reasons, when you would not send an error back. So that's already a little bit leeway for exactly when you need to send an error message. But apart from that, we think that we should just clarify that it's the EAD specification that defines when you're sending and what you're sending. And then ad hoc is adapting to that. That's our proposal. Would that make sense to you, Marco?
Marco, yes, makes sense to have the specification defining the ID, defining whether to send the error message or not exactly, but then it's also better to clarify the general rule than to exclude from that any processing, specifically the processing of the ID items, right?
Right. Yes. So,
Okay.
so does processing also cover actually, that's, yes, the answer is yes.
Okay.
So that should be clarified. Okay, any other comments or views on that? Okay, next. So here's another very specific comment from Marco. This is about connection identifiers, which we talked a lot about previously. They are essentially 3 bullets at the top is defining how connection identifiers are encoded. They are byte strings, raw byte strings, and typically encoded as CBOR byte strings, except in the case when they happen to be the CBOR encoding of a 1-byte integer, or 1-byte CBOR encoding of an integer. And that's, in that case, it's just left. It's basically represented as that data string. So the current text is speaking, is formulated, as you see the old and the new here. The current text is using CBOR diagnostic notation to express this. And Marco is proposing that we should actually not use CBOR diagnostic notation because we are talking about an object which is a raw byte string. So that means that instead of H21, we should use 0x21. And I think that makes sense. So, these are 2 examples, and there are other examples as well. If this makes things clearer, then let's do it. Anyone objecting? No?
No, I hear none, so I propose we do this. Yep.
Okay, next, please. We had 2 comments about reference to the security analysis. And the only reference we make today is the sentence in the first bullet, which is basically listing 2 analysis made previously. And now we have 3 more analysis that is in where there is, the analysis is made, but there is nothing to reference. I mean, there is preprints or they are not even available. We just know that the analysis is made. And in that case, we will definitely need to update this sentence. But the question is if we should do more. So if you compare with TLS Appendix A, there is a more or less security properties listed and references made directly to different analysis publications, which is of course a larger effort to make. We have already a security document which is listing the properties, and yeah, there might be overlaps as well. And so I'm not really sure how to handle this. The simplest way is just to add the references and then be done. But a more ambitious setting here is to try to pinpoint exactly what each analysis is contributing to the document. So I'm open for input here, and in particular if someone is interested in writing this.
So I guess the sensible default is just the references.
Yeah, add to this list.
Yeah, and in terms of updating references and preprints, that you can worry about that in the RC editor queue stage. So.
Right, so we can put in these references for now, yeah. and then we can
they'll get updated later.
Update them later, yes. So let's start there, and unless there are other opinions, then we'll go for that.
Looks like nobody's in the queue, so I guess, yeah, unless somebody provides some text in a very near future, then just the references, I guess.
Okay, thank you. Next. And this is actually John's point. I don't know, John, if you want to take it or if I should do it.
I can take it. So this was just pointing out that this was an option missed when this was discussed. It has been discussed several points in the before, but so when we discussed using, for example, AES CTR, we discussed either using AES CTR or using CCM with a plain text as an input and then remove the tag. But the easier way to do this is to do like today and derive a key stream. So you do a encrypt with your AAD and only zeros, and then you store the beginning of that key stream or ciphertext with the plain text. But don't really think myself that we should do this, but just wanted to make an issue to have it that we have discussed it.
So a clarifying question, John, would doing this change affect the security analysis being that are already done?
I don't think so. No, it would make things a little bit more complicated. You will need to derive keys, but you would derive keys. The only benefit I can see is that it would make us NIST compliant. NIST has some rule that you cannot use your key derivation functions to derive like other random data, but that has been criticized a lot by for example, Kravchuk. Um, if this is not secure, then the whole KDF construction is completely broken. So I don't, yeah. Um, maybe you would have to rerun formal verification. I don't know, but the output would definitely be that it's okay. But um,
Yeah, but
So can you just clarify the change? It's not clear to me.
the change would be to derive key stream 2 from an AAD instead of from the ad hoc KDF HMAC. Another benefit for this would be that you would get rid of the appendix
with large key streams.
key streams.
so my take on this is if we are going to do this, that we should involve the security analysis teams again. So this would be my, at least consulting one of them on seeing how it impacts the analysis.
I don't think John is proposing us to do it. So if no one is doing that, then we should just note it.
Okay.
As I said, my proposal is that we don't do any changes at this late stage.
Okay. Oh, okay. So the proposal is not to do the change and keep things as is, as if they were formally analyzed. Okay. Do we have any opinions on this way forward? Okay, I hear none, so I propose we don't do this, we skip it, we document it and we go forward as is.
Okay, then I think it's the last slide. So, okay, so next steps would be to address these comments and submit updated version of ad hoc. And considering the decision to not change test vectors, we may be saved from updating traces at the moment. Any final comments?
So assuming when we send a mail to the list with the minutes and what, nobody changes their minds, what's the likely timing on the update? Do you think, roughly?
In November?
Okay.
If we get some input on state machine.
Yes. Okay, so if the state machine is perfect, or we decide not to put it in either case, we should be able to hit publication requested at the beginning of December.
hopefully.
Okay, and if there's lots of discussion about the state machine, it'll be August next year.
Earliest.
Yeah.
Okay, so I open the can of worms.
So yeah, so please be aware that if you are going, when they post some text about the state machine, you know, one of the options is not to include that text and be done quicker. But we'll see what we see. Okay, great. Thank you.
Thank you. So the next one in the line is Marco with the hackathon report and the update on the traces draft. We will switch.
Hi, this is Marco. This is an update from the hackathon testing activities and on the lake traces draft. Next slide, please. On the lake traces draft, we submitted a new version before the cutoff. Now both traces, same ones in terms of setup, are aligned with version 17 of EDOC. I produced those from my implementation for Californium. And a lot of things remains the same as in the previous version, especially in terms of the setup for the two peers. So authentication credentials, methods, identifiers, and so on, and a little bit of processing up to the derivation of TH2 and GXY when preparing EDOC message 2. But otherwise, really anything else changed, of course, especially due to the 3 changes in the protocol that Joran highlighted here for the sake of computing PRK3, TH3, and TH4. So a lot changed at the end of the day. Next slide, please. Right. Before submitting this new version, Malaysia was able also to confirm the correctness of the second trace with this implementation. So that's the trace with CyberSuite2 using CCS as credentials, key identifiers, and static. I'm aware that there are additional test vectors from Marek, also covering the same CyberSuite, but also with method 0. They are available online, and yeah, they are consistent with version 17, in spite of what the URI said, because there was no change on the wire between version 16 and 17 of the protocol. Next slide, please. So that was about the traces draft. About the testing, we had quite a lot of testing during the hackathon, me and Malaysia, both with implementations up to date, again, to version 17 of EDOC. We basically tested, first of all, the same thing we tested at the previous hackathon. So considering the same setup, you can just see from this figure that, yeah, we successfully interrupt, and again, we're highlighting that this is the exact setup where you can achieve the smallest possible size for message 2, 45 bytes. Next slide, please. And for the first time, we managed to test the same configuration, but with swapped EDOC roles. Now that Malaysia supported also the responder role. And again, successful interrupt with same nice thing to highlight about message 2. Next slide, please. So I'm aware of other people updating their implementations, especially Marek from Assa Abloy should have his implementation version 17 ready. We were planning to interrupt already before the hackathon, then we ended up having conflicting schedules, and now we're going to reschedule anytime soon, but we will have those tests. And also David is working on an implementation we should be able to test. And we actually started during the hackathon without being able to complete a full protocol execution. So more tests will come. On the actual traces draft, we think it's stable and ready in principle for working group plus code, but it's actually better to be sure that EDOC is in turn really stable first. So the plan is if there is not going to be any change on the wire for EDOC anymore following its working group plus code, I think we can consider this version 3 of the traces for working group plus code as well. If there is any change on the wire for EDOC instead, well, we produce new test vectors and submit a new version of traces for that. So it can stay on hold for a few weeks or so, I guess.
Yes. So before doing the working rule plus call, I believe we need to validate trace number 1 with another implementation. That's for sure. And it would be ideal to ship first ad hoc so that we know that it's frozen, so out of the working group at least. So to publish this new version of ad hoc and then to go for working group last call once we are sure that there are no changes. So that would be my opinion.
Sure. I mean, I guess there's no rush in publishing the traces. They can wait as long as they need because they're available all the time.
Correct. Yeah, that's it.
Okay, thank you, Marco. So now we are going ahead with non-chartered items, so the presentations of possible future work. So first presentation is by Joran on lightweight authorization for ad hoc.
Thank you. So this work started in the ACE working group 3 years ago, approximately. And now we have been waiting for ad hoc to be in a fairly stable state before we actually bring it to this working group where it probably belongs. So the next slide, please. So it has been requested in this working group that we should give more detailed examples of how we're using the external authorization data, EAD fields. And that's an integration point in ad hoc where you can support authorization of peers. And that typically involves a trusted third party. So we'll see several examples here. This draft is looking particularly at the case of using vouchers for authorization. So the initiator is retrieving a voucher from a third party, an authorization server, and that is authorizing the responder. So the initiator knows that this is the right network to join, or the right responder to talk to. And other examples are remote attestation, where the trusted third party would, for example, be a verifier, and revocation checking, where it would be a CA or some PKI functionality, as we have an example in the next presentation. Next slide, please. And just a few reminders about what EAD is, what the ad hoc specification is saying about EAD. So it's defined in section 3.8. There is more details in Appendix E on using EADs, and there is some text in security considerations. And all these three have a lot of warning signs, and the ANA registration procedure for EAD items is specification required. And that's what this draft is doing. It's specifying one of these use cases. Next slide, please. So if we look at an onboarding, device onboarding setting, we have a device and we have an onboarding node, and we're going to run this over a constrained link. And then we have one or more multiple third parties that are available from the onboarding node point of view over internet, for example, or some unconstrained network. And the typical way to do this is that you start with the handshake, the AKE protocol, and then you run one or more authorization protocols in sequence. And that's illustrated here with the blue and red box. And there are potential inefficiencies here if you want to optimize this, both from a latency point of view and from a processing and from a power consumption point of view. So one thing to do is to look at the sequential processing and see how you can make things more in parallel. Another thing is that you can collect the data which is carried over the constrained link multiple times and perhaps not send them multiple times. And the third thing you can do is that you could use the unconstrained network to get the information that the onboarding node needs without transporting back and forth over the constrained link. Next slide. So in the particular example which this draft is containing, there is a voucher retrieval protocol. So now the red box from the previous slide is moved into the black box, which is the AKE, in this case ad hoc, with its 3 messages. And the red protocol is carried in the EAD fields. So you have, in this case, there's a voucher info going in E day 1, which the responder turns into a voucher request for the authorization server. It gets back a voucher in the voucher response, and that is passed back to the initiator with the message 2. So after message 2, you could, the initiator can authenticate and also authorize the responder, and if not authorized, abort the protocol. So this is addressing the issues with mentioned in the previous slide. Next slide. So here is the details of the protocol, or some of the details. And this first, we look at what are the trust relationships we assume between these nodes. For some reason, we've given the nodes names U, V, and W. That's so mapping from the previous picture. That's slightly confusing because we already have letters for the initiator and the responder. So U equals I and V equals R. So we'll think about that in the next version. But U is not assumed to have a relationship with V. This is basically the object of the onboarding process, that you include the device in the network. Instead, U is having a relationship with W, which could represent the manufacturer, for example. So U has a trusted public Diffie-Hellman key of W, and that's used, that's pre-provisioned in factory, for example, or at some warehouse, and that's used to encrypt the message going from U to V in the voucher request. So in the EAD1 field, we now have two objects. One is the encrypted identity of the device of U, and the other is the locator of W, which could be a URI, for example. And then V is running the protocol with W. It gets back a voucher, and the voucher goes in EAD2 back to U. So that's a bit focus on U and V. And if we now go to the next slide, we see what happens between V and W. So this is an unconstrained link or network. And here we assume that there is just an ordinary web-based trust with implicit trust anchors. So V and W can set up TLS. And in this, with this connection, the voucher request and response is passed. The voucher request contains information from message 1. For example, the hash of the message 1 as a session identifier. There is a selected cipher suite, which comes out of the suite's I field in ad hoc, which is the same cipher suite being used between U and W as U and V in this version of the draft. And the ephemeral key also from ad hoc. And from the EAD fields, we take the encrypted identifier of U and a proof of possession of the public key of V. So with this message, the W can first of all decrypt the identifier of U. It can then authenticate, sort of prove the possession of the public key of V using the POP-V field, and then make the decision about authorizing or not V in this join procedure. And if it's authorized, if V is authorized, it constructs a voucher, which is typically the MAC of the session identifier and the credential used by V, cred R.
Just as a time check, we would need to wrap up. So.
Okay, so that's good. Because I'm done. Okay. So this is, we have already got very good comments from Marco, and we'll make a new version, and we're implementation in progress or in planning. And if anyone is welcome to join, there is open source ad hoc libraries to use. Thank you.
Great. So I think we'll take any questions or comments on the three presentations at the end, just in the interest of time.
Yes. So the next presentation is by Yusuf. Yusuf, can you hear us?
Yes. Hello.
Okay. We hear you loud and clear. Thank you. The floor is yours.
Thank you.
Yusuf,
Can I control?
If you can do this in about 8 minutes, that would be fantastic.
I'll try. Can I control the slides, please? So
You can, but I can take it back though if you take it too long.
so where do I? Yes, passes you the slides control. Perfect. All right. Hello. Thank you for having me. I'm Yusuf Abdul Khalik, and I'm gonna talk about certificate revocation in resource-constrained environments. And this is a master's thesis. And the idea is that we're leveraging OCSP and ad hoc to achieve this certificate revocation. So let's dive in. The idea here is we're considering a communication scenario where we have a constrained node as ad hoc initiator, and we have a non-constrained node as responder. And now there is one more step of authentication required from the responder, as the initiator also wants certificate revocation information. And just very quickly, when a private key is compromised, certificate is revoked, and you need to tell the network somehow about this, or else there is it doesn't mean anything that you revoke the certificate. And we're trying to achieve this now, but in a constrained environment setting. We're considering the responder to be an initially untrusted responder. It might be an adversary that's leveraging the absence of this revocation information transport. So how can we achieve this in a constrained environment? How can a constrained node get this information? The idea is, or was, to look into transporting this information via a lightweight key exchange protocol ad hoc. How can a constrained node acquire? There are some ways. We're going to look through them very quickly. There are certificate revocation lists, but the idea is these are too large. We're talking sometimes unlimited size, so you're not going to have a constrained node download these and cross-reference ID cred with them to see if the certificate is revoked. That's not going to happen. So that completely removes CRLs out of the equation. Then we go to OCSP, Online Certificate Status Protocol. And the idea here is we can have the initiator query the revocation status of the responder certificate doing an OCSP request. But now you're saying that the initiator or the constrained initiator has to support a library to perform an OCSP request, meaning it knows ASN1, it knows DER encoding. So again, maybe it's asking too much of it. And also you want it to have a connection with an OCSP responder. Again, maybe too much. So what's better then? The better thing is that we try to leverage OCSP stapling, and then we remove the whole load from the constrained node. Let's talk about OCSP stapling. So now going back to our previous structure, we have the constrained node as ad hoc initiator, again, same thing, but now we have an OCSP responder in the equation here. And the idea is that to perform stapling, the constrained node we're going to see how exactly right now, but it somehow tells the responder to not only give its certificate, but also please staple an OCSP response onto that certificate. And that's the idea of stapling. The staple is the OCSP response on top of the responder certificate. Now, the thesis provides a vector of doing that, and it uses EAD items again, and Yuran has went through those in the last slide. The idea is in ad hoc message 1, in EAD1, the constrained initiator generates a staple request. And we're going to see what that looks like right now. But the idea is we know that EAD1 or EAD is a sequence of EAD items, and we're looking at EAD value here. The EAD value we're going to call here staple request. It contains responder ID list and fresh. Responder ID here refers to trusted OCSP responder ID. And the idea is that the responder must respect this list, and this is taken from staple request in TLS. It's the same idea. That the responder must respect this list and give back an OCSP or contact an OCSP responder from that list, because that is the only way that the initiator can then verify the signature of the response. Because Well, yes, that's the trusted responder, and accordingly in the trust store, there is the public key of those trusted responders, and accordingly you can verify the signature. What about fresh? You can see, of course, maybe we can disagree on the naming here, but it's an optional item, and it says that the initiator wants a fresh OCSP response. So just to very quickly go through it, when you do an OCSP request, if you add a nonce, then it doesn't give you a cached response, but gives you a fresh one. Now, according to the policy regarding freshness periods in your application or on, or maybe in how you use the protocol, you decide when to ask for a fresh response. Just very important here, the AED label is a negative label because this item is used as a critical AED, meaning it can affect...
2 more minutes, apologies.
Sorry?
So we'll have to wrap up in 2 minutes.
Okay, okay. Yes, then we go to the OCSP request. So now we understand it can perform the OCSP request after it got the staple request. Just very quickly here, OCSP request, when we get it, we get a 1600 bytes response, which doesn't really work. There is no possibility to re-encode because on the initiator needs the response to be signed. It doesn't trust the responder. We have gone through this. So accordingly, the thesis proposes a tiny version of the OCSP response. But how do we ask for this tiny version? We use the preferred signature algorithms to signal a tiny request in OCSP request. Now going back here, now the responder has received the response in EAD2 as a staple, and the responder sends this as it is, including the staple tiny OCSP response. Let's look at how that looks. And this again here, this will be in EAD2. This is staple response is the value, and inside is tiny OCSP response. And this is a profile which allows to achieve the functionality of acquiring the revocation information, but still be within the security considerations. But because of short time, we won't go through that. Very quickly now, to complete the structure, the initiator receives the staple response. It can verify produced at to see if it works with its own time. It can verify ID cred R, and then it can get the certificate status and accordingly decide whether to continue or discontinue ad hoc. Very quickly here, this new OCSP response gives 83% reduction compared to using normal OCSP. And then the idea is it removes signer cert and also removes, of course, the RNAS and one structure, meaning
so
that...
we're at time. Sorry, can you wrap up?
Yes, great. Then, yes, this was showing the transport overhead in ad hoc, just the implementation. Soon there will be 2 pull requests, both to OpenSSL and Stefan Ristosov's US Core U ad hoc library. And that is that. Thank you.
Okay, just a clarifying question. Do you plan to submit this as a draft or this is just a master thesis for now?
So no, the plan is to, if it is found appropriate, is to definitely submit this as a draft.
Oh, okay, thank you.
And again, Marco, if we can...
Absolutely. We'll do my best. Next slide, please. This is a possible additional topic for Lake. While reviewing and implementing ad hoc over the last 2 years, I ended up thinking of a number of side points that I believe rightfully are out of scope for the actual ad hoc protocol, were left out of the ad hoc specification, but still I believe an implementers has to face them when implementing ad hoc and ad hoc library, whatever. And yeah, I think guidelines would be useful. I started to think of 3 areas to start with. What do you do if you have to, for whatever reason, invalidate an ad hoc session or invalidate application keys derived out of an ad hoc execution for the format that may be, I expect, typically because of authentication credentials expired or revoked. The latter case is trickier. Ad hoc per se is fine, the session is fine, but application keys have become invalid to use, for instance, because you breached the crypto limits or whatever. What do you do? You run ad hoc altogether, you run a lighter key update. Can you still do that if the ad hoc session was not persisted? What if ad hoc was not simply run standalone, but in a more complex context, like as an access control framework execution, and an ad hoc session is bound to access control credentials? That's an area. The second area is You are fine with trusting authentication credentials you are storing already. They might have been provided by a trusted third party out of band or whatever. But what do you do about credentials that are new for you that you can learn in principle on the fly as transported by value in Credex? I've always seen pointers to what I call trust model 1 and 3 here, that you extremes of the spectrum. So you never trust anything new that you receive in ID Credex by value if you don't know it already, or you trust everything you see in ID Credex as long as it is valid. I argue there's a middle ground where you can still trust something brand new that you see for the first time on the fly, as long as it is valid and you are already storing a trusted identifier compatible with that. And next. And this would be a third possible area about the actual processing. And I believe, again, that rightfully the ad hoc specification focused on what I call here core ad hoc processing, already saying all in all that in some spots you may have to divert from the main processing to take care of, for example, validating credentials, processing EAD items, and sometimes the latter influences the former. It is just said very generically, oh, give those things up to the application for their processing. You can't exactly go all the way out to the application or good luck getting back. So you need some careful design and consideration to do that in a callback fashion, so to say. And believe me, the big box with the ABC point can be in turn exploded with a sort of state machine, which is not trivial to think about. Next slide, please. And that's the last one. This is just what I thought so far. My plan was to propose an informational document to give this kind of guidelines. But first of all, I take the opportunity to ask to the group, to the chairs, if this is in scope and appropriate for Lake in the first place. If anything more should cover, and a draft would be welcome to consider at least. Thank you.
Sure. Yeah. Okay, so I think we have like 4 minutes left. I'm going to suggest that what we might want to do is when we get to hit the publication requested for ad hoc, then maybe schedule an interim meeting where we can accept suggestions for work like this with a bit more time to allow them to be discussed. Does that kind of make sense to people?
Sounds good to me.
So I'm guessing that would be either just before the holidays or just in the new year or something like that, maybe. And so we can ask people on the list to make suggestions in the lead up to that. But I think if we can get the publication requested button hit first, that's probably a safer thing to do.
Yeah, so we focus on characterizing, of course, but what crossed my mind is like what we were discussing about the finite state machine, about the state protocol state machine could as well go into the draft that Marco was proposing on implementation guidance. So that would be, I think, also an appropriate kind of home.
Yeah, about that, if the ad hoc draft covered any state machine at all, it will probably be limited to what I call core ad hoc processing anyway, because that's what that draft defines it.
So yes, so let's discuss this at the interim beginning of December or mid-December.
Well, so I'm suggesting that we first hit the publication requested,
Okay.
and then schedule the interim.
Sounds good.
Because otherwise people will just get carried away.
Okay.
Is that okay?
Yeah, that sounds good for me.
Okay, so basically we're going to try and get ad hoc to hand it off to the area director for his review, and then we can discuss in more detail future work items and things people would like to do. Okay, we have like 2 minutes.
Any other comments? Any other business?
If not, thank you. Thanks for all the work getting this stuff done. And all the implementation. It's really good to see. And assuming people want to do more work, we might see you next time. If people turn out not to want to do more work, maybe we're done. We'll see. Thank you. It's funny because the Meet Echo rooms, they just close really quick.
Yeah.
You get about 3 or 4 minutes as well.
Okay.
Yeah, that state machine thing, I would be worried that text could take forever.
Yeah. Because I would need to. Yeah, I implemented it I did it for my implementation.
Yeah.
But without